Okay, in this video, we're going to compute the specific value of a derivative of a specific function at a point. So this is the function f of x is x squared plus x, and I want to compute the derivative at x equals 2. Okay, so to do that, I'm going to use the definition of the derivative. So the derivative at 2 is defined to be the limit as h goes to 0 of f of x plus 2 minus, f of 2 plus h minus f of 2 divided by h. And this is going to go to f of 2 minus f of 2 over h. So it's going to go to 0 over 0. So we need to do some sort of simplification to see whether this limit exists or not. So right now we're not sure. And to do this simplification, we need to use the definition of f, right? So f of 2 plus h, what do? I take 2 plus h squared and I add it to 2 plus h. And f of 2, what do? I take 2 squared and I add it to 2. So let's use the definition of f to simplify this. So this is 2 plus h squared plus 2 plus h. So that's f of 2 plus h. And then I'm going to subtract f of 2, which is 2 squared plus 2. That's 6. And still I'm dividing by h. And so now we can simplify. So I'm going to expand this out and simplify. So this is limit as h goes to 0. So 2 plus h squared, what is it? It's 4 plus 4h plus h squared. And then I'm still adding 2 plus h. And then I'm subtracting 2 squared plus 2. So I'm subtracting 6. And I'm still dividing by h. And now the constant terms cancel, right? There's a 4, there's a 2, that's 6, and then I'm subtracting 6. So if I simplify this, this is limit as h goes to 0. And I think what I'm getting is, I'm going to collect these terms here. So I get 4h and h, and I have h squared. So this is h squared plus 5h. And then the constant terms cancel, right? And so I'm still dividing by h. And so now this is still going to 0 over 0, but you see now I can factor out an h. So this is the limit as h goes to 0 of h times h plus 5 divided by h. And so these h's cancel. And as h goes to 0, this is a continuous function in h, right? So this is just 5. I plug in h equals 0 and I get 5. And so the derivative at this point is 5.